Hello everyone. Today class we see how to convert gray to binary converter, how to design gray to binary converter. Okay, in previous section we see binary to converter. Okay, so before we going to design, we just see the circuit and truth table of the gray to binary converter. So this is the circuit diagram of the gray to binary converter. So there we going to use 4 bit. So this is the gray input, and we going to get the binary output. Inside we going to use the XOR gate. Okay, so this is the truth table. We're going to check this truth table with the simulation output. So we can to know come to know that this is circuit diagram and also the truth table. So we're going to design gray to binary in the Xilinx platform. Okay, so just click new project. Here we're going to give the file name. So I'm going to give gray to binary. So get to binary. Next we going to select the device and speed and the language which going to design. So VHDL or Verilog. Here I am going to use VHDL code for the design. So I am selecting the VHDL code and finish. So you can create the file name. Inside the file name we are going to create the source file. So for that, just click the new source and select the VHDL module and give the source file name gray to binary. So next here we going to give the input. Okay, so if you check this circuit diagram, means here we going to use G4 input, gray input, and 4 binary output. Okay, so just to give G input bus 0 to 3. Okay, and B output that's 0 to 3. Just click next, finish. Here we going to design. If you check, means B3 will be the come from G3, so B3 output will be the G3 input. Okay, so B3 directly come from the G3 input. Next we're going to give output value for the B2. B2 will be the G3 XOR G2. Okay, B2 will be the G3 XOR G2. Next B1 will be the G3 XOR G2 XOR G1. Okay, so B1 will be the G3 XOR G2 XOR G1. Okay, so next B0 will be the G1 G2 XOR G1 XOR G2 XOR G1 XOR G0. Okay, so we design the circuit diagram in code, in VHDL code. Just we want to save and we want to check whether there is any error in code or not. So if green color mark is came, means then there is no any error. If red color came, means there will be error, and also the which line we done the error also we can able to know. So here we give the input in array form, so we want to use that in the bracket. Okay, So now we check the syntax. Okay, so there is no any error. Now we check the RTL semantic. So in this RTL thematic only we can able to know the circuit diagram. Okay, come to know whether the circuit diagram is right or not. Whatever we done in code is in RTL semantic only we can able to see in design form. So we using 1 2 3 4 XOR gate, right? 1 2 3 XOR. So this one XOR will be the I am using in the inside. Okay, so next LUTs, how much LUTs area we going to use in FPGA, we came to know in technology semantic. We using 3 LUTs. If you check LUTs means we can able to see the XOR gates, K map and the truth table. So how many inputs and how many buffers we using, how many LUTs we using in the FPGA kit, what we selected in before we enter the code, right? That we can able to see in the technology semantic. So if you check the design summary, in this design summary only you can able to check the area and delay, and we also check the power report. So whatever the design we going to design means we want to first check the area, power and delay. So here your LUTs we going to use is 3, input output is 8, and the delay will be the 7.850 nanosecond. Now we check the power, static power in place and route, analyze power distribution. Translate, and now after translate the map will be run. After map the place and route will be run. After that only the Xilinx XPower analyzer will be open. In that we can able to see the power analyzer for the what we designed. So XPower analyzer window is now opening. So now we see the how much power. So taking 0.060 power watt. Okay, next we check the simulation. So for that we want to create the test bench. Why we going to create the test bench means because we going to give the input, right? So that input will be we want to give in the test bench and also the delay. So here we give gray to binary TB. Next finish. So here we remove the inbuilt timing, okay, clock process and all. So here we going to give G is the input, 4 input. First we give the 0 0, okay. Next is G, sorry we using capital G. Next will be G 0 0 0 1. Next will be 0 0 1 0. No. 0 0 0. Okay, now I'm giving just 4 inputs. Okay, so we check whether is similar with truth table or not. We want to save. Okay, if any error means that will be shown, if no means then so there is any error. So here I've saved. Then the simulation window will be open. We can check that windows with the truth table. Okay. So if you open means 000 is 000. Okay, 001 is 001. Okay, 0010 is 0011. So right, 0100 is 0100. Okay, 0100 is 0111. So right, 100 is 41. Okay, so right. So what we done is now is correct. We will give the test bench for another input also. Okay, so we design grade to binary and we check the area, power and delay and also the simulation window. Okay, next class we see with another example. Okay, thank you.